Bienvenidos, Ushamdi, and welcome. CTS230, Section 841 students for the Fall 2017 semester at Anne Arundel Community College. This is the Networking 3, or the Scaling Networks V6 course from Cisco Networking Academy. And this packet tracer tutorial and solution set is going to be on Packet Tracer Activity 2.3.1.5, where we're going to configure layer 3 switching, or in other words, we're going to be configuring multi-layer switching. So let's go ahead and dive in to the activity. It's a very straightforward activity. Not a lot of heavy lifting here, but we are going to talk about what happens behind the scenes when that no switch port command gets run, because it actually ties in with our conversation about extended range VLANs. And so we want to make sure we know what's going on behind the scenes there. So we have our addressing table here, and we're just going to jump onto this multi-layer switch, and let's see, is it going to, oh, beautiful. All right, so the multi-layer switch, it seems to be the 2960s are the only switches not cooperating with that large font that I've selected. So here's what we're going to do. We're going to be setting up this switch. And again, it's not a router, it's a switch, and we're going to be setting it up to perform routing. In fact, it's Inter-VLAN routing. So let's go from user exec mode with greater than sign to privilege exec with the enable command. And then we're going to transition into global config with the configure terminal command. Now, it actually tells us here, here's what you're going to do. This is what needs to be done. And we're peering right now, or our gig 02 connection is with our quote unquote internet service provider. So let's get into interface gigabit ethernet 0/2. And let's do a quick do show run and see what we've got here. Now, remember that gig 02, right? This port, if I was to say, and let's run that command now, do show interface gigabit ethernet 02 switch port, you can see that it has negotiated to an access port, right? And it's set to dynamic auto. We're about to change all of that by issuing a single command, which is no switch port. So in other words, we don't want it to be a layer 2 port, and this is how you convert a layer 2 port on a multi-layer capable switch into a routed port, or in other words, a port that you would see on a router. We're going to be able to do layer 3 routing. And so as soon as I say no switch port, you can see what happens is that gigabit ethernet 02 comes up, right? So now that that port is up, let's stick an IP address on here, 209.165.200.225, is that right? Yeah, and it's a /30, so 255, 255, 255, 252 is our dotted decimal notation for our subnet mask. Now let's go ahead and confirm, can we ping 209.165.200.226? And that is our neighbor address, right? And we're directly connected, so we don't have any issues there at all. Now, before we move on to take a look at the Inter-VLAN routing component here, and I like this activity for two reasons. The first is it shows us really both ways to tackle this problem from a multi-layer switch perspective. The first is we simply convert a switch port into a routed or a layer 3 port, and then we're actually going to be setting up Inter-VLAN routing by creating switch virtual interfaces. So we're really kind of doing two tasks that are both ways to perform layer 3 activities on a multi-layer switch. Now, before we transition to the Inter-VLAN routing, that no switch port command, right? It's important that you understand what's going on behind the scenes, because if I'm on this switch, and let's see if it shows it here. If I say show run, and I'm looking for, and it doesn't look like it's going to have it, it may not have it on here. So let's actually go to a real Cisco switch, and this is a 3750 switch here, ALSW01. If I go from user exec to privilege exec and I say show run include, and we want to include policy is the word that I'm looking for. So show run, and we're going to pipe it to include policy. And so we're looking for this command right here, VLAN internal allocation policy ascending. Right? Now you may be wondering, What does that line have to do with me saying no switch port? Well, quite a bit when we talk about those extended range VLANs, 1006 to 4094. So if I were to say show VLAN brief right now, you can see that I don't have any VLANs configured at all. So let me go into global config. I'm going to go into interface fast Ethernet 101, and I'm going to say no switch port, right? So now when I say do show interface fast Ethernet 101 switch port, and I hit enter, we get a much shorter amount of output. This is not an error. This is not a mistake, right? Take a look at that. It basically says the switch port is disabled. So by saying no switch port, we've disabled the switch port. In other words, we don't need to see all of the information, and I'll do FA 102. We don't need to see all of that information because it's irrelevant. We've turned it into a layer 3 routed port. Now, back to that policy ascending command for the VLAN internal policy ascending. If I say do show VLAN brief, right, we don't see anything here. Okay, so you may think, yeah, no big deal. And you decide, you know what, hey, I want to use those extended range VLANs, so let me go ahead and flip this to VTP mode transparent. And then I'm going to say I want to use VLAN 1006. And I'm going to name it faculty. For whatever reason, that's the VLAN name you wanted to give it. Now, at this point, you're probably thinking, okay, great. So you're going to use VLAN 1006, and we're going to call it faculty. However, as soon as I type end, in other words, when I exit the VLAN subconfiguration mode, I'm going to be greeted, and I better be greeted with some messages here on switch ALS W01. And here they are, right? So we get some syslog messages that are going to pop up to the screen, and this is what's going on. This is why we're getting this message. You can see we get the port manager facility, the switch facility, VLAN in use, VLAN create failed, and configured from console. So take a look here. It says VLAN 1006 currently in use on fast Ethernet 101. Well, how is that possible? Because we turned this into a layer 3 port. So what's going on there? And then you can see this VLAN create. Failed to create VLAN 1006. VLAN not available in the port manager, and you can see why here. Extended VLAN in use. And so here's what's going on, and here's how that command, right, that syntax that we saw in the running config when I said show run include, and I think ascending is going to get it for us, that VLAN internal allocation policy ascending. What's happening when you convert a switch port into a layer 3 port on a multi-layer switch? Your VLAN internal allocation policy ascending says that the first port that gets converted, that port will start in an ascending fashion in the extended VLAN range at the first available extended VLAN. In other words, 1006, because we had no other VLANs configured. So I say no switch port, and fast Ethernet 101 gobbles up VLAN 1006. So it goes outside the normal range VLANs to take one of the VLANs, because what's happening behind the scenes is it's really just an SVI, right? It's really a switch virtual interface on the back end behind the curtain that we don't see. We think when we type that IP address command in that, oh my God, it's a router port. But really what's going on is behind the scenes, it's just a switch virtual interface. It's software on the switch that is making it capable of taking that port and turning it into a layer 3 routed port. But again, behind the scenes, it's all being done with a VLAN and this SVI. Now, if I was to say do show run, we'll never see that SVI, right? You're not going to see interface VLAN 1006 toward the end of the config with the IP address in there. Because again, it's being done for us sort of auto-magically behind the scenes. And so let's walk this out here. Let's see what happens. Remember, I'm in transparent mode, so the policy is ascending. If I go into global config here with the conf t command and say VLAN 1007, VLAN 1008, VLAN 1009, so I've just created those VLANs. When I say do show VLAN brief, there they are. And again, the last one's not going to show until I either create another one or exit from the VLAN subconfiguration mode. But the key point being is I was able to create those. So let me ask you this. What happens when I go into interface fast Ethernet 102 and say no switch port? Do we get any error messages here? And again, that's not an error message. I don't have anything plugged into the port. But do we get any error messages with respect to, hey, the VLAN internal allocation policy is ascending, and the next available, right, it should have been 1007, but I'm using 1007. So again, the switch knows, it checks, it sees, hey, he's using 1007, he's using 1008, but here's the question, did it get 1009 or 1010? What do you think? Show VLAN brief is going to give us that answer. Well, 1007, 8, and 9 were already used, so what is the internal VLAN that should be assigned to that? It should be 1010, and here's how we can check that, is I can simply say VLAN 1010 or 1010, and then exit, and take a look at that. So again, this is all going on behind the scenes, but this is what's taking place. When you convert a switch port, a layer 2 port to a layer 3 port, the switch is going to grab the first available extended range VLAN, and it's going to use that to behind the scenes, right, being very sneaky here, create a switch virtual interface that does all of the work for us, right? But it gives us the feel of, hey, I'm on a router because I configured this port as a routed port and I put an IP on the port. But really behind the scenes, it's nothing more than an SVI that's being created. All right, so again, a little sidebar there, but very, very important, right? Very important to understand what that command is doing. So now let's transition back here. And we're going to add the switch virtual interfaces. And again, this is very straightforward. So I come into global config. And now remember, this is different than saying, and I'll create a couple bogus VLANs here. So when I say VLAN 90 and I say name test, did I just create a switched virtual interface, a layer 3 interface? No. In fact, remember, I just created a VLAN. Right? That's just a layer 2 VLAN. However, when you say interface VLAN 10, now I'm creating a switched virtual interface, a layer 3 interface that is in VLAN 10 or reachable via VLAN 10 on this switch. And so we can see the IP address, they give it to us, 192.168.10.254. And typically, 99.9% of the time, this is going to be the default gateway for my PCs on VLAN 10. And it's going to be a /24. They kept it simple, right? Now, I don't have to say no shut because it's automatically do show run. I typically say no shut out of habit, but it's auto-magically if there's a port there in the up state. So here's interface VLAN 10, and I've got an IP address assigned. That is my layer 3 switch virtual interface. Now let's do the same thing for interface VLAN 20. And again, the IP address command is going to be the same with the exception of the third octet reflecting the VLAN number. Same thing with VLAN 30, right? So very simple to set this up. You can see we're getting native VLAN mismatch, and we'll work through that here in just a second. And so there we go. So we just created those 3 and it came back with bad mask. Let's see, did I typo something here? All right, VLAN 30. Oh, it looks like 252. It looks like something happened there when I went to type in that right there. Everything else is okay. Yeah, it threw up an error message, and logging synchronous is probably not on. It's not. So my text got, my input got mixed up with the, and yeah, that is not the subnet mask there. Should be 0. My 0 got changed to a 3, and that caused some issues. We'll say do show run, and that looks much better, right? So we're set up there. Everything looks good there. Now, how to enable routing? Because right now, the question would be, so I've created these layer 3 switch virtual interfaces right here. So VLAN 10, 20, and 30, all the PCs are using those IPs as their default gateway. So let's verify end-to-end connectivity. Now, I'm definitely switching this enable routing part here, but it's, again, to demonstrate the importance of that IP routing command, which is critical. So if I come back to the drawing here, let's pull PC0 up. And let's examine PC0 real quickly. We'll take a look at the IP config, 192.168.10.1, and there you go. The default gateway, in other words, the layer 3 default gateway or default router for the PC0, is that SVI we just created. So, can I do Inter-VLAN routing? Well, first let's check 192.168.10.254. Can I ping my default gateway? And after an ARP packet goes out, we should see that we get a response back. Oh, wait, I'm sorry. Did I? We've got that native VLAN mismatch. Let me take care of that native VLAN mismatch because that is definitely an issue. So I'm pulling switch 1 up because switch 1, let me guess, has probably got that port configured as an access port, if at all. So let's say show run, and again, I apologize, this print is tiny here, and it actually is a trunk. So what is the VLAN mismatch about between the multi-layer switch and switch 1? On gig 01, it says that it is VLAN 1. And here it clearly says switch port trunk native VLAN 999. So we may be dealing with a little bug here. So let's see if we can sort this out. So let's get into global config interface gigabit 01 and take a look there. It's still kicking back that error message about switch port trunk native VLAN 999. Let me type it in manually there. I'm going to say shut, and you can see the ports have gone red. And then I'm going to say no shut, but we get that native VLAN mismatch anyway. Let me make sure. Did I configure that over here? Do show run. And I am certain that switch port, but here's what we don't have there. Now, not to say that we need it, right? Because that port there, that gig 01, if I was to say do show interface gig 01, gig 01 switch port, you should see that it's dynamic auto, right? There were no statement there for switch port mode trunk. So it's dynamic auto by default. That's the default DTP mode. But the operational mode, the mode that we negotiated to for the trunking, was trunk, because on the other side it's switch port mode trunk. The in cap was negotiated as .1Q, which we expected, and DTP is on this port. And there is the native VLAN. So here's what I'm going to do. It's possible this is a little bug here. So let's go ahead and get into interface gigabit Ethernet 01. And I'm going to say switch port mode trunk. Okay, let's do switch port trunk in cap .1Q or switch port TED. And then let's say switch port mode trunk. And let's see if I do a shut, and again, just shutting it down and no shutting it to clear things out here, and hopefully, we don't get that error. So it appears that to get rid of that native VLAN mismatch error, at least I hope that is what was going on there. Let's allow the spanning tree to converge here. State is up. We are not getting those error messages, so I'm very hopeful here that that is going to be the fix. And let's give it a second here, and let me check the other ports on this switch. Switch 1. And it's interesting that none of the other ports on switch 1 here, gig 02 is not configured with anything. Okay, so it looks like it's using fast Ethernet ports, and those are hard-coded. Okay, so that is up. Let's come back. Now let's see, can we ping? Because here's what we're trying to do. We're trying to ping through PC0, through switch 2 to switch 1 to my layer 3 default gateway here in this multi-layer switch for VLAN 10, 192.168.10.254. Now, the reason it didn't work the first time is because this link here, we had that native VLAN mismatch, even though we didn't. Packet Tracer believed that we did, and it was causing a problem. So let's come back to PC0. Let's rerun this command now, and we should have success because VLAN 10 now has connectivity all the way through. So can I ping that SVI? And I cannot. All right, we'll give it a second here and allow it to time out. All right, so we've configured the SVIs. And let me check the instructions here real quick. All right, so we don't have the IP routing command on, but is that the problem? So if I come back to switch 1 here, let me see, did we have, so VLAN 99 is 99.1, and let me check and see, do show run. Let's see if we have a VLAN 99 pre-configured. We do not. All right, so we'll follow this through here. They're definitely wanting that command. So the IP routing command, this is the command that enables routing on the switch. Now, this command should not be needed coming through switch 1 as I'm looking at this, because we're coming through VLAN 10. It's on that trunk, and we've got the trunk port configured. We should be good, but let's put our IP routing command in, because that is what enables Inter-VLAN routing on the switch. So if I pull PC0 back up, I will be surprised here if that brings it back up, and it doesn't. And I'm definitely convinced that, are we missing? Let's take a look here on switch 2. Do we have any VLANs configured? So it didn't appear to be part of the activity over here. And looking at this, it doesn't say anything about creating the VLANs, or if it does, I missed it. Yeah, it doesn't say anything, but let's see if that's the case here. Let's go ahead and get into privilege exec, show VLAN brief. I should have, okay, VLANs 10, 20, and 30 are there. Let's check switch 1, show VLAN brief, or do show VLAN brief. And the VLANs are there. Did we have them here? Did I miss? Do show VLAN brief. So we don't have those on the multi-layer switch. So did I go by configure and activate the SVI? All right. Add VLANs. I certainly went right by it. So add VLANs. I had assumed those were already there. So my mistake on that. So fortuitous failure here, right? VLAN 10, name staff. VLAN 20, name student. VLAN 30, name faculty. Again, I apologize there. I had assumed that those had already been provided for us. And now let me go ahead and do something a little unorthodox. I'm going to say no IP routing, because again, I want to show you that I don't need IP routing on to have reachability to ping an SVI. That IP routing, and there we go, right? That IP routing is going to allow inter-VLAN routing. Again, it's going to allow that multi-layer switch to behave like a router. So as soon as I say on the multi-layer switch, as soon as I add this IP routing back in, what that's facilitating for me, and let me scoot up here because we'll ping across, what that's facilitating for me is from PC0 and VLAN 10, I can now ping across to the other VLANs. And so let's go ahead and say, let's ping 192.168.20.1. That's PC1 on VLAN 20, and I'm probably going to have to ARP out. And then I've got connectivity, right? Because now the traffic, when I ping from PC0 to PC1, what's happening is PC0 looks in its ARP cache, right? It says, hey, I need the physical address, the layer 2 address for my default gateway that's configured here on PC0 when we go into that IP address configuration dialog box area. So it sends an ARP packet out, it broadcasts it out to the all F's MAC address, and it's basically saying, hey, I'm configured with a default gateway of 192.168.10.254, which just happens to be the IP address for SVI, for the SVI for VLAN 10 up here, right? So on this switch. So the ARP packet goes out. The multi-layer switch, right, sees, because it's in that broadcast domain for VLAN 10, and again, this is limited to VLAN 10, but the multi-layer switch sees it and it's going to respond back and say, hey, I'm 192.168.10.254, and here is my layer 2 physical MAC address that you need to use when you're creating frames to send to me. So PC0 sends that ARP out, and now the next ping packet that goes through is sent to the default gateway, and the multi-layer switch gets it. And now that we've enabled multi-layer switching, right, or inter-VLAN routing on this multi-layer switch, it internally switches it for me, sends it back out to PC, what did I say? Who did we ping? Whoops, going the wrong way. Over here to PC2, right? So it doesn't come through here. It just comes straight back down through switch 1, switch 2 to PC2. Because again, it's in a different VLAN. So what is not happening, right? Don't be fooled. It's not doing this. That is not how the routing is taking place. Because switch 2 is a layer 2 device. And these broadcast domains that PC0 and, I'm sorry, I pinged PC1, I apologize. Same difference though. It doesn't do that, right? PC0 and PC1, they are in different broadcast domains that are mutually exclusive from each other, that are segmented via the layer 2 construct, the VLAN. And so again, PC0, when it sends traffic to PCs and other VLANs, will have to send that traffic. It's going to have to come up here and come back down across those 2 trunk links down to its final destination. And again, that is multi-layer switching. So let's do one more here. I'm going to ping PC. Let's get PC0 back up here, and let's say ping PC4. So 192.168 dot, and we're looking at 192.168.20.2. And this will ARP out, right? It's going to say, hey, the first ping packet, I don't have the default gateway in my ARP cache anymore, so I need to ARP out for it. So again, and this is what I was drawing earlier, the traffic comes through switch 2 to switch 1 up to our router, right, our multi-layer switch, who's behaving like a router, sends the traffic back down, kind of hairpins through switch 1, and then comes over to switch 4. And return traffic, right, ICMP replies are coming back that opposite path. And that is the function and the value of a multi-layer switch, because all three of these switches here, right, when it talks about the scenario, it says a benefit for a small to medium-sized company would be the ability to purchase a single multi-layer switch instead of different, separate switching and routing platforms. In fact, what you could do here, and let me clear this real quick, what you could do here is all of these PCs could be plugged in. Everything could be directly into this multi-layer switch. And we create the VLANs on the multi-layer switch. We put the switch ports into the VLANs that are required. And we get rid of, because when you look at this, I mean, these are fast Ethernet connections here anyway, right? That's possible congestion. I can put everything into that single multi-layer switch, and I achieve the same process, but I don't need switch 1, I don't need switch 2, and I don't need switch 3, right? So again, from a realistic perspective, the best way to do it would be to just get that single multi-layer switch and then start plugging your host ins, create the VLANs, do your layer 3 routed port here with the no switch port command, and off you go. All right, well, this, and actually there's one last thing that I want to mention here that just as we're talking this through that occurred to me. So from PC 0, can I ping the internet, right? What would be the quote unquote, the internet. So let's try that. Let's ping 209.165, because we want to try to make this as realistic as possible, .200.225. And we can, because we're directly connected to that. Now, here's the challenge. It doesn't have it on here. If I pull the multi-layer switch up and I say, show IP route. So take a look at that. That's my routing table. I know how to get to the three networks, VLAN 10, 20, and 30, and the 209.165.200.224/30 network, right? So would anybody in this network right now, PC 0, 1, 2, 3, 4, and 5, would any of these PCs be able to hit Google, right? Let's say that, that Google's out here, right? Or Amazon or Netflix or whatever the case may be. Would any of those be able to get out here? So PC 0 types in www.amazon.com, or if it knew the IP address for Google, right? It tried to ping 8.8.8.8. Would that work? And that's definitely something you need to think about here. The answer is no. And we're going to learn about why the answer is no. And I'll tell you right now, it's because we don't have a route to get to the 8.8.8.8. In fact, what would we have? What kind of a route do you think we would have on this multi-layer switch that would facilitate this kind of a conversation? Traffic shows up at the multi-layer switch from any of those PCs, and the multi-layer switch says, I don't have a more specific route, but I do have a default route. And my default route says simply go to, send all the traffic that I don't have a more specific, longer match to get to, just simply throw it out my routed port that I've configured out to my internet service provider. And so again, let's go into global config here and let's see if it allows me to do a default route here. And the next top IP is 209.165.200.226. And now when I say do show IP route, there is my statically configured default route. And again, I wanted to pull this into the conversation because it's going to take more than what we have right here for all of these PCs to access anything beyond that interface right there on the cloud. And the only reason that we can get to this segment right here, the interface is on that segment, is because it's directly connected to our multi-layer switch. And that is our quote-unquote router. But we need more, if we're going to be functioning in a fashion where, this guy sitting here at PC3 wants to go to Amazon, right? Or wants to go to Google or whatever the case may be. So I just wanted to pull that into the conversation. Now, interestingly enough, it is saying that we're at 87%. So let's check the results real quick here. What is it saying I missed? Okay. So it wanted us to configure something for VLAN 99. I had looked at that earlier and saw that there was nothing configured. But let's go ahead and round things out here. So interface VLAN 99, and the VLAN 99 IP should be 192.168.99.254, and that is a /25.0. All right, there we go. So we took it to the 100% completion rate. We had some additional conversations, which are very important. That material, those two topics we talked about, that default route, as well as what is actually taking place with that no switch port command behind the scenes. And when you see that line, that VLAN internal allocation policy ascending, on some platforms you can change it to descending. So it'll start at 4094 and work its way down instead of at 1006 and working its way up. All right, well, this activity is not due, so you don't have to upload this activity this week. Again, this was just a supplemental video. It's a great packet tracer activity that I wanted to go ahead and demonstrate because it definitely touches on the topics that we're dealing with. All right, well, this is going to wrap up packet tracer activity 2.3.1.5. Have a great weekend, and I will see you all on Tuesday evening.